All right, welcome back. So today I am going to address the geometric distribution. There is a reason why we call it geometric, because it has something to do with geometric series, which you have seen in pre-calc and maybe calculus as well. And the geometric distribution happens to be a discrete distribution, just like the binomial, unlike the normal distribution, which is a continuous distribution. And there is a slight difference between the binomial distribution and the geometric distribution. The binomial distribution had 4 conditions, if you remember. Okay, the geometric distribution shares the first 3 conditions, but it definitely does not have this 4th condition. In fact, that is the distinguishing feature of the geometric distribution. For a random variable to follow a geometric distribution, number one, it has to fulfill those 3 conditions that is shared with the binomial. But it also means that the number of trials is not only that it's not fixed, it's not known ahead of time. The way it works is like this. So let's say I flip a dice, and let's say success would mean to get a 3. To get a 3 is success. Not to get a 3 is failure. So there are 2 outcomes, right? Either get a 3 or not getting a 3. Obviously, those events are independent. And let's say each one has a probability of 1/6 if the dice is trial. So the probability of failure is 5/6. If you don't get a 3, that's a 5/6 chance. If you get a 3, that's a 1/6 chance. And those P and Qs don't change at all. Now, what we want to do is flip a dice until you get the first 3, right? So the number of trials, not only that it is not fixed, we don't even know how long it's going to take us to get the first 3, okay? The first thing we always do is create a table. So X we'll take these values, and I want to make 2 comments about the top values. If you remember, you can go back to the YouTube video. The binomial distribution, if you remember, that number here was 0. In other words, 0 means you have no successes. Let's say you flip a coin 20 times, and let's say success means to get a tail. It is possible that you flip a coin 20 times and you never get a tail. So it's always, if you remember, it's always begun with 0. But for this type of distribution, it cannot start with 0. You would have to flip the dice at least once to have a chance of having success. Does that make sense? So that's the first comment I want to make. The second comment is, it is possible that you keep flipping a dice, and you never get the 3. We're looking for a 3. Remember, 3 means success. Potentially, you could just keep flipping the dice forever, right? Potentially. Most likely it's not going to happen, but potentially it could. It might take 104 trials. It might take 1,000 trials. You might get it on the very first trial. On the very first trial, you get a 4. So potentially, you may never get it, right? So the table doesn't end, and that's why I put 3 dots. Now, what does this mean? This means P of X equals 1 here. Okay, I'll write it here in green. This means P of X equals 1. And what does that mean? It means you flipped a dice and you got a 4 on the very first trial. That's what it means. Sorry, I think we said 3. You flipped a dice and you got 3 on the very first trial. And that probability, don't say 1/6, right? Because we don't know if the dice is fair or unfair. Let's just call it P. Okay, I know you'll be tempted to write 1/6, but it's not. So what does this? Now it's going to make more sense. Watch this. This is the probability that X equals 2. Now let's make sure we understand what this thing in green means. Probability that X equals 2 means you got a 3, the 3 that we're looking for. Remember, the dice has those values 1, 2, 3, 4, 5, 6, and we decided that 3 means success and not 3 is failure. P of x equals 2 means you got a 3 on the second trial, which means you did not get 3 on the first trial, and then you got a 3. That means you failed, and then you succeeded. See? So if it is a fair dice, that would be 5/6 times 1/6, right? Because if you don't get a 3, that means you either get a 1 or a 2 or a 4 or a 5 or a 6. So there is a 5/6 chance. But I don't want to assume that the dice is fair. So I'm just going to use failing, which means Q. The probability of failure is Q, and then success. Now, what does this mean here? This means P of x equals 3. It means you succeeded on the third trial, which means you failed on the first trial, and then you failed on the second trial, and then you succeeded. And that's why we had Q squared times P. Okay? And succeed on the fourth trial, it means you failed 3 times, and then you succeeded, and so on and so forth. Okay? Now, what's the probability that x equals k in general? Not 1 or 2 or 3 or 4, but k. That means you succeeded on the kth trial, which means you failed. That's the probability of failure. You failed on all the previous steps, and there are k minus 1, right? Because you succeeded on the kth one. That means you failed on the first, second, third, all the way to k minus 1, and then you succeeded. Does that make sense? So this is the general case for these, okay? All right, so this is the formula to find the probability of x equals any value k. K is just a parameter, a number like a 1 or a 2 or a 3, okay? Now, as you know, we always make sure to check if this probability function is legitimate, okay? Notice that we know that P and Q are both between 0 and 1. So clearly this is between 0 and 1. And if you multiply a number between 0 and 1 by a number between 0 and 1, that number stays between 0 and 1. If you square a number between 0 and 1, it actually shrinks even more. So it is still between 0 and 1, multiplied by another number between 0 and 1. So all of these values are between 0 and 1, okay? So that's easy. The second one is hard. Now you might say, well, if you have this on a test, do you have to check these? The answer is yes. However, on a test, you're not dealing with letters. You're dealing with actual numbers. This is like, say, 1/6, 5/6 times 1/6, 5/6 squared times 1/6. So it's easy to check the conditions because the numbers will be given to you. But I'm working in general. So how do we know that this sum is exactly 1? And I want to show it to you because I think you'll appreciate it, okay? So how do I want to find this sum, okay? And I want to make sure that it is 1, okay? That's what I want to do next. So I'm checking the second condition, right? So if I add these numbers forever, right, potentially with 3 dots, what you notice is they all have P in common. So I factored out P. That leaves me with 1 plus Q squared plus Q cubed, and so on and so forth. And if you remember from series and sequences, when we dealt with series, if you have, this is a series is a sum. So like this is a sum. If you have a sum where to move from one term to the next, you always multiply by the same number called the common ratio. In our case, it's R. If this series is geometric, which means you're always multiplying by the same value, like 2 plus 4 plus 8 plus 16 plus 32. You're always multiplying by 2. It's called geometric series. If it is infinite, and if that common ratio, R, is stuck between -1 and 1, then you are guaranteed that the sum is the very first term over 1 minus the common ratio called R. Okay? I hope you remember this. And it's not hard actually to prove, but it's kind of outside of the course, so I'm not going to waste time showing you why is it that if you have an infinite geometric series where the common ratio is between -1 and 1, the series converge to this number. So that's all I did here. Notice that this is geometric because I'm always multiplying by q to get to the next term. Am I not? Don't look at p, okay? Just look here in between the brackets. So I'm always multiplying by q. Q is playing the role of r, okay? Now notice q, by definition, is between 0 and 1. Isn't q between 0 and 1? Probability of failure, which means it is already between -1 and 1. So since q is between 0 and 1, by definition, that means q is definitely between -1 and 1, right? So this common ratio called q happens to be between -1 and 1, and because it is infinite, this is an infinite sum. I don't know when this is ending. It has to converge, and it converges to the first term over 1 minus the common ratio called q. But 1 minus q, by definition, is p, because p plus q is 1. Isn't that true? P plus q is 1. I'll write it here. P plus q is always 1. So that means p is 1 minus q, but also q is 1 minus p. You can use them anytime you want. So 1 minus q is just p. So that's 1 over p times p, which is p over p, which is 1. So that sum is 1, and therefore this is a legitimate probability function, okay? So the last thing I want to do, obviously, every time you have, you know how to find the probability of x equals any value or less than or more than, we need to know the mean and the standard deviation of this random variable. And I'm actually going to prove to you the mean, but I'm not going to prove to you the standard deviation. It is a lot more complicated. It's doable. Maybe toward the end of the year I could do that for you. So how do I find the mean? The mean has many ways to say it. You could say the mean of x, or you could say the expected value of x. You remember? We claim that the mean is 1 over p. Okay? Now remember, the binomial distribution, the mean of x was np. For the geometric distribution, it's 1 over p. Let me go back here quickly to remind you. Do you see that we said this is an infinite geometric series? That's why we call it geometric distribution. That word came from the fact that we always use geometric series, okay? And we're going to use geometric series again when we deal with the mean. So this is a claim. I'm making this claim. So how do we do that? Remember, the mean is just this times this plus this times this plus this times this plus this times this. It's like an weighted average, right? So it's 1 times p plus 2 times pq and so on and so forth. I'm just copying exactly this product. This times this plus this times this plus this times this plus this times this plus dot. Okay? That's all I did here. Okay? So I'm going to play a trick. I'm going to take this equation. I'm going to multiply both sides by q. I have the right to multiply both sides by q. Multiply this by q, you get this. Multiply this by q. This becomes q squared. This becomes q cubed. Now, I'm multiplying both sides by q because we assume q is not 0. And then what I'm going to do next is I'm going to take this equation and I'm going to subtract that equation. So here it is, okay? So the mean of x minus q, the mean of x, is this minus that. And here is what you notice. The p remains, okay? This p remains. And then this minus this is just pq. You know, like twice 2 pencils minus 1 pencil is 1 pencil. So 2pq minus pq is pq. And 3pq squared minus 2pq squared is 1pq squared. And this minus that is this, and so on and so forth. Right? Now, notice here there is a p in common, so I factor out a p. So I'm left with 1 plus q squared, and so on and so forth. And we just did this before. This is an infinite geometric series where the common ratio q is between -1 and 1. And therefore, the sum has to be the first term over 1 minus the common ratio. I just did that here. Okay? So that is just this. Now let's go back here. This is, I factored out the mean of x. So the mean of x times 1 minus q equals p times, p times this stuff. Now 1 minus q is p. And that p cancels. P is not 0, so I can cancel. When I cancel, I get the mean of x equals 1 over 1 minus q, which is 1 over p. I did this just to practice a little bit on series and show you this nice little trick, okay? So the mean of x for a geometric distribution is 1 over p. And then I'm just going to give you the standard deviation or the variance first. I'm not going to prove it to you. It's doable, but it's a little more complicated. So just take this for granted for now. The variance of q of x is q over p squared. Now you could feel free to write q as 1 minus p. So some books write it like this and some books write it like that. Again, we don't care about the variance, we care about standard deviation, but we always pass through the variance first. So the standard deviation of this random variable, this geometric random variable, is the square root of 1 minus p over the square root of p squared. Now square root of p squared should be plus or minus p. However, we know that p is positive, so we don't need to worry about the bars, okay? So the answer is just p at the bottom, okay? So for now, what you need to know is a geometric distribution has 3 conditions. Make sure you double check to see if it is a legitimate probability function. This is the formula on how you figure out the probability that x equals some constants. I will deal with less than or more than later. And then the mean is 1 over p, and the standard deviation is the square root of 1 minus p over p. Hopefully this is not too hard. Take care.